Okay. Thanks a lot, Sébastien, for the introduction, and Gregory and Sébastien for inviting me and giving me the opportunity to discuss with you about this intriguing topic, the security aspects in AI-driven network management. So basically, when I started to think about the structure of the presentation, okay, the first point is to try to convince ourselves that we need AI. It is a buzzword today, but do we need it in network management? So the very first part will be on to cover a little bit these aspects, to try to see in which sense and how it can improve network management. So it is straightforward then to consider that when we introduce AI, machine learning, of course, we are changing the security landscape, in the sense that AI itself is introducing new vulnerability. This means that basically there are new threats that we do not have basically if we not use AI. And I try to cover a little bit the main threats in this sense. But the other point was at the certain point I started to ask myself, okay, but imagine that we don't want to integrate AI, ML for network management. Do we still need to ask a question about how AI, ML can impact network management today? You will see my conclusion is yes, I think it is like that. And I will conclude my talk by considering the approach that we are adopting in our lab in terms of security management in network. So the main rationale to introduce, to integrate AI in network management is basically because, of course, is permitting to improve automation optimization. And it is also permitting to enhance cybersecurity aspects. In this sense, there are, of course, critical intersection of artificial intelligence and network security. What is sure is that a lot of enterprise are up to date adopting AI, integrating AI to enable the network management. And there is for sure some improvement in network operation. And certainly one of the best points is related to the improved capability of threat detection. So artificial intelligence is imposing itself basically as a transformative force in network management, and we cannot neglect this point. It is possible to improve, enhance the analytics, and above all, to process a massive volume of data. That is the strength, the strong points of AI, but also the weak points, the data. What is sure is that the type of threats with the integration of AI and machine learning is becoming more and more sophisticated, and there are specific new type of vulnerability that are targeting network. And what is noticed also is that there is a global cybersecurity talent gap that is widening. So there is a need to improve and train the capability of talent in order to face to these new aspects. And concerning this new capability, in terms of networking, what is happening? What is going on? I'm considering this picture that, in my opinion, well represent the up-to-date situation of network. That we can see is it has been adopted. It is basically in the evolution of IoT towards the concept of IoT edge cloud continuum. And it is a subject we are working on in a current European project because at a certain point it really gained momentum, this paradigm of IoT edge cloud continuum. And the main reasons are related to the fact that the previous paradigm where IoT devices were simply objects sending some kind of metric like temperature or pressure is in a few years is completely changed. And we have the concept of IoT that is very large. As you can see at the very low layer, IoT devices are up to date, simple sensor, but also more complex devices like, for example, connected vehicles or drones or home-based IoT devices. So we have a range of really heterogeneous devices in terms of capability and in terms also of energy. And one of the main reasons to introduce to have this kind of migration in terms of paradigm is related to the fact that asking the service for the application directly to the cloud was basically impractical from an energy point of view, but also in terms of cost. And it is for that this kind of hierarchical structure, architecture with far edge, near edge node has been introduced in order to bring very closer to the IoT devices the nodes with a certain capability to bring application. And it is in this context that we consider, for example, the different aspects related to how the integration of AI, ML can improve the network management. In this context, basically, in my lab, we mostly work on the low layer, so on IoT devices and far edge devices. And in this context, what we can notice is that the integration of AI and machine learning approach bring an improved capability in terms of predictive maintenance. And this is basically the main reasons why several enterprises are also introducing ML. Because basically it permits to anticipate, to prevent the certain failures, and this permits to keep the connectivity or to reduce at minimum the lost connectivity. And it also permits to identify and localize the point of failure. And also in terms of anomaly detection, the fact that there is an improved capability to analyze a massive volume of data, of course, is permitting to advance in this sense. Another key point is related to the resource allocation that can be realized in a more dynamic way. But let's come to the subject of my speech. This new type of paradigm, the IoT Edge Cloud Continuum, is introducing a new complexity. And the picture that I'm showing here, the title is not visible, but basically it is the posture of NIST in a presentation of 2022. And as you can see, it is trying to capture this kind of complexity by introducing four main pillars. The green one, the green module is, for example, to let understand that based on the high heterogeneity, it's not possible to consider one solution in terms of cybersecurity that could be suitable for everything. And there is an increased need also to strictly collaborate with diverse stakeholders regarding tools, regarding standardization, etc. In my opinion, the most interesting points are related to risk-based understanding and the ecosystem of things. Why? Because basically the blue one, risk-based understanding, is capturing the fact that we need to regard the specific characteristic of the IoT devices, but in the new and evolved version. And the second one is strictly related with this blue one because basically we cannot limit ourselves to analyze the IoT devices, to apply very reinforced cryptography or coding approach without regarding how these devices interconnect to each other. Because the vulnerability often are based not on the strength of the cryptography approach, but on the fact that we are in face of dynamic networks that are characterized by different stages. And for example, recently it has been proven that in 5G infrastructure, the one vulnerability is related to the handover mechanism, where basically there is not any control and a fake, a rogue base station can take the control without being detected. So, keeping that in mind, I will now try to analyze with you the main attack related to the AI models. So the ones that I said we have because we are adopting machine learning models, and we do not have basically if we do not consider that. And basically, there are four main type of attack in respect of AI model. Model theft, model inversion, poisoning attacks, and evasion attacks. So concerning the model theft, the point is that advancing in the capability of machine learning and having more and more complex machine learning that treat different large amount of data, making sure that, of course, we would try to have the benefit aspects of the machine learning, but maybe we don't have all the capability to run very heavy machine learning approach and to make the tuning of hyperparameter, etc. So A new type of paradigm in this sense appeared that is related to machine learning as a service. And basically, there are a business model like paper query, where it is possible, for example, to make a query and to receive a response elaborated by a machine learning model. This is really intriguing in terms of application, in terms of services. The main problem is related to the fact that there can be a malicious attack related to that. A very nice contribution that I advise you to read if you are interested by this topic is this one, this survey that has been published in 2023. And where basically the stealing machine learning model had been described together with also some defense. Another type of attack is related to the model inversion. So basically, it is consisting in the fact that specific queries are carefully crafted in order to have a certain output from the machine learning model. And they can be collected and analyzed in order to identify with the other machine learning approach the specific pattern and try to extract the information related, for example, to proprietary algorithm. The ones that we are looking a little bit closer are the so-called adversarial attacks. The adversarial attacks are characterized by the fact that basically the attacker, the malicious user, probe the system and try to understand which are the threshold, the boundary, in order to perturbate the machine learning model, the data of the machine learning model, and to obtain a different outcome. And basically, this is starting, this type of attack, of adversarial attack, is starting to be more and more sophisticated, with difficult to detect the difference between the data that are not manipulated and the one that are manipulated. And both poisoning and the evasion attack are part of this adversarial approach. The difference is basically consisting in the fact that in data poisoning, the manipulation or injection is done on the data that are trained. And it can consist on, as I said, manipulation by injection or modification of the data. And why it can happen? Because, as I mentioned, in the case of theft attack, there is this system, for example, with machine learning as a service approach, where there are also public data sets that are available, that can be accessed, are open access, basically. And they can be subject to such type of poisoned injection. But also private data sets are not completely immune to this type of modification. And basically, this is related also to the type of evolution in the IoT Edge Cloud continuum, in the sense that up to today, the IoT devices can be physically accessed, and this means that they can be modified, for example, to change the type of data that they produce. So it is for that it is important to consider the IoT edge cloud continuum as an ecosystem of things. The main objective of poisoning attack is to have performance degradation by reducing, of course, the accuracy or efficiency of the machine learning model. It can be also related, this is typical, for example, to the vehicular application where signs are introduced to be detected by the vehicle, and there is a trigger pattern to make a misinterpretation of the street sign. There can be also a label manipulation that will completely mislead a classifier by changing label, and this impact basically on the completely resource and network management, because, for example, if a legitimate user is identified as a jammer node and the jammer node is identified as a legitimate user, of course, all the action that will follow will be completely wrong. And also for model steering by influencing the training to favor a certain outcome. The last attack related to the adversarial attack family category is the one called evasion attack. Basically, it is consisting in the fact that the attacker crafts adversarial network packets. The point is that here I'm mentioning just network packets, but the fact is that we can also think about manipulation, perturbation of signal, because we are all this data that are traveling on the air, and also perturbation of signal may have an important impact in terms of attack. And indeed, the MAGMO attack is such a type of example. It is a very interesting attack that has been presented this year in NDSS, and is consisting in universal perturbation. Universal because basically it is agnostic in respect of the protocol that is adopted, and because it is based also on the design of a perturbation generator model, because one of the main problem of such a type of attack is related to the fact that if they are based on machine learning approach and then data that are capturing the characteristic features of the channel, normally they may have problem to adapt in a different environment. But the researcher made insert to address the channel variability through the design of this perturbation generator model. And what is also interesting is that it is basically an type of black box attack. So they do not make any assumption related to the knowledge of data. This type of attack has been realized for audio and video, and the researcher also showed the capability of the MAGMO attack in a real test bed. So basically, what we can observe is that there is an improvement in terms of sophistication of the attack. So the last attack that I mentioned, for example, is a good representative of such type of sophistication. And when a AI machine learning approach model are integrated in network management, what is important to do for sure is to implement the data quality framework. So data is the crucial point in this sense. The provenance of the data should be carefully verified, and above all, there should be also anomaly detection that are evolving together with the attack in order to be capable to capture every type of anomaly that can signify a perturbation, an adversarial attack. This also means that there should be a regular retraining. So the point is that up to date, in my opinion, is still difficult to establish if there is a real gain in terms of really cost, energy consumption. If we even look to all the work that has to be done to integrate AI and the effectiveness of AI itself. But for sure, with improvement in the approach and improvement in the capability to detect the attack, it will completely make sense. So, regarding the specific type of attacks that are related to the network when we integrate machine learning, artificial intelligence to manage them. The question that I was wondering is, imagine that we do not have machine learning itself to manage network, but we want to consider, for example, how machine learning could be considered from the devil point of view. So if we consider that we want to create attack by relying on them. So basically, what we observed was that, of course, it's possible to improve already existing attack and also to think about new type of attack that are relying on machine learning. And some few years ago, we started to think about a structure, a kind of taxonomy of machine learning approach and type of attack. So the starting point was to consider in the context of the network the passive attack. Passive attacks are the ones that are more difficult to detect because basically they do not inject anything, they do not change data. But basically they are based on capability to collect and analyze data. For example, cryptanalysis attack or side channel attack where data leakage can be exploited to infer, for example, sensitive information are undermining the confidentiality, and it is not so difficult to implement such type of attack with supervised machine learning approach. And what is interesting is that it is possible to do that also in presence of encrypted data. So encrypting data is not the panacea for all the problem. Another important point is that active attack are often based on the results of passive attack. And we noticed, for example, that availability attack like replay or jamming, advanced jamming attack or spoofing attack can be realized in an efficient way by considering unsupervised or reinforcement learning. And I will present one of these examples. But also integrity attack can be effectively realized by relying on unsupervised or reinforcement learning approach. So let's start with the very last part where I will consider the use of machine learning in order to improve the security management of network. So it is a little bit changing the target is a type of management of network, but really the security part. I come back once again on this representation and in this context, I will present an attack that we realized some very few years ago in 2022, called Icaro, that is basically a targeted drone jamming. At this time, we were working on a drone, but as you can see, Icaro is related to Wi-Fi protocol. So we were targeting drones that are based on Wi-Fi. And basically, such type of attack is suitable for every type of Wi-Fi node, not only drone. The main point was the main problem was that there are certain drones that fly on forbidden zone, and maybe they fly also together with other drones that are legitimate, or they can be they can be in the same location together with other legitimate nodes that are not drones. And they are emitting basically on the same frequency that can be 2.4 or 5 gigahertz. The point is that at the time we were working with a company that is specialized in drones, and the contract measure that they had was based on emitting a signal in the same frequency of drone. But the main problem is that from one side is jamming all the neighborhoods, so it was cut-offing basically all the not emitting in the same frequency. And the other problem is that it consumed a lot of energy and it was easily eating. So what we were searching for was to try to target multiple communication protocols. So to try to find a rationale that permit us to extend our approach to different communication technologies, not only the Wi-Fi, by just modifying a little bit the approach. To adapt to the environment, to be able, for example, if there is also a countermeasure to evolve and to be effective also in presence of evolved attack. To not demand the collection of too much data and to not rely on too much data, because what we want to do is to implement our approach in IoT devices that are, for their nature, not very resource constrained, and also in terms of energy should be effective. And based on all these characteristics, we wanted to create a framework. So, as I said, we started by considering Wi-Fi, and we started to think about the nature of the different packets and realizing that we don't need to focus on all the packets, but to counteract a drone or a node, basically it is sufficient to target a probe or a synchronization packet. Then, by discussing with colleagues on machine learning, we realized that such type of problem can be easily modeled through a reinforcement learning approach, a multi-arm bandit, where we considered that the action can be jam or not to jam the drone, because we have to imagine that we are also in presence of multiple communications. So we have to target the good drone and not the other. And basically, what we needed is to grant that there is an interaction with the environment, so we can understand if jamming has been effective and relate to that an award that can be 1 or 0 based on the results. We implemented that on Raspberry Pi, and we started by testing it indoor. That is not the most natural environment for drones, but the main rationale was related to the fact that indoor is a much more complicated environment for concurrent transmission with multipath effect, fading, etc. So if it is working indoor, we also tested it outdoor. And the other point was also that we wanted to make it more general and not only for drone. So we considered what you can see, the testbed that is working also in the same frequency, 2 drones, NFT and BPOP, and the victim that is an NFT. So the victim, in this case, what we considered is that this type of attack is a friendly jamming attack, and it is needed in the context, for example, of network management, because if a jammer node is identified, it should be in some way isolated in order to avoid to deplete all the resources for such type of node. The attacker, as I said, was implemented in a Raspberry Pi, and we considered the packet delivery ratio to be measured. So some results, we started the attack after 30 seconds of working of the network. And we implemented also comparative jamming attack, the constant one, the reactive one, and a random one. And what we noticed is that the very left picture, the effect in terms of dropping the packets was very effective, like a constant one. I recall that the one implemented by the company we were working on was also related on emitting a constant signal that is much more expensive. We also considered the capability of Icaro approach to not disturb too much the neighboring node, and we actually been sure for the time of for the duration of the attack the impact on the other nodes, and we noticed that basically the type of impact is quite low. For that, we also measured the energy consumption, and we noticed that it is basically very close to the random jamming for the duration of the attack, of course, and also reactive jamming that is not effective was consuming quite more energy. Another approach that I wanted also to present in this context is related to a robust authentication approach. Because in the context of the complex network that I presented before, we really believe that we cannot develop advanced solutions that are also respecting the constraints in terms of resource, the energy, disregarding the physical layer aspects. And physical layer security solution can be implemented by considering also cross-layer approach and by combining with the upper layer approach. And in this direction, we recently developed a robust device authentication in multi-node networks. So we considered basically the presence of different nodes. And we relied on the assumption that is verified in any case, that two nodes that are identical, are the same brand, etc., the same model, they are characterized by intrinsic hardware impairment that are very difficult to replicate. And what we started to do is to analyze the effect of the impairment to see if we can actually obtain a specific signature of each node, also for two nodes that are very similar. And we started by looking at each impairment independently, but it's quite difficult to derive a unique signature in this sense. And we also started by approaching with a statistical approach, but it was also quite complicated. And by analyzing these aspects, what we realized is that if we combine more, and in this paper we considered three hardware impairment, CFO, DCO, and PO. If we combine them and we pre-treat them with a specific signal processing approach, we can actually create a signature when a node is emitting wirelessly. The only assumption in this case to recognize, detect a node as legitimate or not is that basically we need to know the nodes, the legitimate nodes. We need to have their signature. This permits us, without any prior knowledge of the attacker, to detect if a node is legitimate or not with a very high accuracy. And basically, this is the framework that we realized. For a sake of time, I didn't report all the detail, but the paper is available also with the code, the data. We also submitted it for artifact evaluation, and it has been successfully replicated. So everything is open access and can be used. So to conclude, basically, it is true that artificial intelligence, machine learning can play a primary role in the network management, but it is still up to date with an important cost that has to be considered in face of the type of attack that can be realized on that. It is undoubtful that it opens a new landscape threat. What we are considering is that to improve the capability to detect false node, malicious node, we cannot disregard the physical layer part of the network by considering the network management. So this is basically my conclusion. Thanks for your attention.
I have a few maybe to start. So in your the whole attack setting, is the victim or the legitimate user using the same Wi-Fi channel or not?
The Wi-Fi channel, yes, in this case is the same. And but we developed later on another type of attack that is capable to follow the channel if it is changed. So to exactly follow the pattern of the channel of the targeted device.
In your slide, you wanted to maximize the effectiveness of the attack, but the energy spent is still 3/4 of the full jamming energy. So if you have a lower energy budget, how much does it degrade the attack performance?
We didn't do the experiments with an energy budget. But we investigated these aspects in other work where we considered the capability to be in the good state at the good moment by modeling the problem as a Markov chain-based approach. And in this way, we can consider an energy budget or we can decide to maximize the attack success. So it was not integrated with this one, but we developed this one as an independent one in the same period in order to be capable to face with this energy problem.
This algorithm is also open source.
It is called Arpagon, and I don't remember because it was submitted to IoT Journal that is not implementing an artifact evaluation. It was not implementing at the time we submitted. So I have to check if it is open source or not, but it seems to me that we didn't make it open source. But I will check.
Yeah, first of all, thank you for your presentation. I will come back to the first part of the presentation when we presented this different types of adversarial attacks. And I have two questions. The first one is the fact that we use now more LLMs in systems. Are these kind of adversarial attacks applicable also in this generative AI models, or there is any specificities? And also in terms of best practices to build a robust AI model. So it's good to detect that we are somehow vulnerable with this adversarial attacks, but how to react? What are the mitigation to finally build something that is more robust and can be applicable in operation?
Okay. Regarding the first question, LLM, of course, is not immune to such type of attack, and maybe is also more vulnerable, and it has been demonstrated because for the moment it's difficult to apply that there is a real reasoning capacity. So LLM basically is powerful because it is based on a huge volume of data, but when we use it for different purposes, for unseen things, we see up to date still the limitations. So I would say that yes, definitely is really vulnerable of such type of attack. concerning the other question, I showed this type of picture because, in my opinion, is really capturing the complexity of the network. And for example, for a company that are based on wireless networks. The main point today is that also with the implementation of smart working, it's very difficult to distinguish, to limit, to a clear boundary between the connected object. In my opinion, the first point is to have a clear idea what is connected to our network, to have the capability to identify, detect if strange devices are connected. Still, this is limiting us for the solution that are available to devices that emit something, because if they are passively listening, there are some research solution in this sense to identify, to detect such type of nodes, but not really available. The other important point is to manage the authentication and authorization aspects that are two different things, of course, but related together. Authentication permits a device to integrate a network, but authorization limit to the strictly necessary. So there should be this minimization approach in mind. Once again, this is related to the fact to be capable to identify the number, the type of nodes that are connected, and to minimize to the strictly necessary. Say that I am biased because we work a lot on physical layer security aspects, but I believe that it is not possible to disregard the fact that a lot of data are moved on the form of signal waves that can be captured in some way and can be analyzed, detected. And when we have good anomaly detection approach, what should be done is to have a system that is organized in a way that permits us to isolate immediately, to localize and isolate immediately the portion of the network that is faulty. This is my point of view.
Any other question?
I was wondering, can the malicious activity by some chance affect also this anomaly detector in the same way that it can affect the machine learning model?
Not sure.
The anomaly detector top of the machine learning model in order to detect malicious activity.
Can be affected also by attack itself. Yeah, absolutely. One of the attack, maybe it was a little bit faster, but one of the purposes is exactly to undermine the capability of the detector when there are perturbation, for example. So basically, it is a type of combination of attack, because there is the analysis part to understand, for example, the model that is running in terms of detection. And when the model is acquired, there is the analysis of the threshold that permit to does just a small perturbation that making sure that the detection, the anomaly detector is not working anymore in a proper way. So it is absolutely a target, one of the main targets.
With that problem of benchmarking all those detectors, because they become very specific to those particular settings.
Absolutely, absolutely, yeah. And the other point is also related to the fact that the rules, the legal aspects related, for example, to IoT and how they should be considered working in a proper way in our home is not very well defined. So there is some reasons project regarding these aspects, but basically it's difficult sometimes to understand that there is something that is not going properly.
Users that are missing from the pictures.
The user is missing, and this is a paramount aspect. Actually, the users and the ethic and legal aspects are not properly considered. And in a recent cost action that I'm chairing, we try to work with the expert criminology, for example, and also legal expert in order to better understand. It's not easy at all, but to better understand how these aspects are all related to each other. Because if I mention the physical layer is important, the human, the way we use the IoT is also maybe more important. You're absolutely right in this sense. So.
Yes.
Thank you for that. I didn't get how you jump only the how do you choose which packets to jump and the other ones from the other ones to distinguish between the
we were capable to analyze, to have in our Raspberry Pi, in our attacker node, let's say, a Wi-Fi analyzer. We use it Wireshark, but it can be also TCP dump or something else. And it is important to highlight that it is for that I specified it is suitable for Wi-Fi. Because for DGI, for example, they are using a proprietary protocol that are completely with encrypted data. I don't remember where I put with encrypted data, and we cannot apply exactly this approach to that. We have to move to physical layer in order to model, to rely on a machine learning model, understand which are the synchronization probe packets at physical layer, and target such this one. Because we were working for this work, we worked at layer 2 where we can analyze directly, we have such type of tools. But it's true that if we don't have, we need to rely on something else.
Okay, thank you so much.
Thank you.